Okay, so listen, I'm gonna talk a little bit about the electromagnetic force and why this stuff is important. Why, how bullies and wimps do matter in your life, and you do engage with them. And for a lot of you, if you understand what's going on, your life will be not only richer, but you know, at least on some kind of fulfillment level. But this people who know about this stuff also, do it for a living. If the world makes sense to you, you got a leg up. So we're talking about bullies and wimps, and bullies attract electrons with more force, and that's by the electromagnetic force, than wimps do. Okay, so electrons move from wimps. They get pulled away by bullies and they move toward the bully. So if we have a wimp and a bully, the wimp will lose electrons, and that's what we're talking about in the periodic table. And so one of the things that I'd hoped to do with you guys was to have you build batteries. And the batteries that we were going to make were, and I drew a picture of it, I forgot that. The batteries that we were going to make were going to be in a. I will give you a scan of this so you can see it, but you should be able to see the pink beaker, right? Despite my drawing, there's a beaker, and in it is salt water, for electrolytes. And they're two metal. So you would have cut, you would have had sheets of metal, and you would have snipped them with these snips, and you would have had, this one is zinc and this one is copper. Okay, so zinc and copper are both kind of electron wimps, but copper is less of a wimp, so it's going to be the bully in this situation. So what we're going to have is we're going to have electrons flowing through the salt water from the zinc to the copper, from the zinc to the copper, and there will be a flow of electrons across that electrolyte, okay, that fluid that carries electrons, from the zinc to the copper. And so what's going to end up then is we're going to have just adjust this, you're going to end up with more electrons in the copper electrode. Okay, so we call those the electrodes. And this will have more electrons. It'll be electron rich, or will have a surplus of electrons. That's the copper side. And then the zinc side will have a deficit of electrons. Okay, so if you think about it, the surplus of electrons, or the extra electrons, gives the copper a negative charge, and the the deficit of electrons gives the zinc a positive charge. Okay, so if you look at that, you can see right there, I drew that for you. Right, the copper electrode has a negative charge. The zinc electrode has a positive charge. Okay, so what's going to happen then is if you connect them with a wire, okay, from the negative, right, because the negative electrode with the copper in it, that will repel the electrons and sort of push them. But on the other end of the wire is the zinc electrode with a positive charge, and that's attracting them. So we have a flow of electrons through that wire, and that's electricity. So this is a battery, and that's how batteries work. The electrons flow from the negative electrode to the positive electrode. And if we put a light bulb in the middle of that wire, okay, what a light bulb is the electrons are going through the wire, da 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 da, and then they come to this tiny little thin wire, and they all get it's like a traffic jam, and they all get heated up and sparked up, and you know, there's light and sparks, and that's how a light bulb works, because all those electrons have to flow through that tiny little thing, and so it all kind of heats up like a traffic jam, and then it comes out the other side and it flows away and over to the positive electrode. Okay, so what I'm going to do here is I'm going to show you my car battery, this one, my truck battery, and this is a car battery is called a lead acid battery, and there's lead dioxide, that's a negative terminal, and then spongy lead, that's the positive terminal. So the spongy lead is the wimp, and the lead dioxide is the bully, and the electrolyte is sulfuric acid. It's a very nasty acid. But I'm going to just pop the hood here, and then I'll show you the. And then I'll be right with you here. Sorry about that. Okay, so if I can get this thing open. Okay, so show you the battery here. Okay, so you might wonder how the thing gets so many volts, right? But probably you don't know that there's not much of a difference. There's only a 2.1 voltage difference, and voltage is the difference between how hard they pull on the electrons, and so the lead dioxide pulls on it a little bit harder, not that much, than the spongy lead. And so if you look at this, usually there'd be 6 caps. 1, 2, 3, 4, 5, 6, because this is actually 6 cells all stacked together. Okay, so we've got this would be the spongy lead terminal with the red for positive. This would be the lead dioxide. So I'm going to take this light, so I've connected the wire to the negative side. Now I'm going to touch the positive side. Doesn't matter which way you do this, and it's not lighting up. God, I've had this thing since 1980. It's the first time it's ever failed. All right, okay. Listen. It failed. I'm gonna be right back. I'm gonna one way or another, I'm gonna show you the traffic jam, and I'm gonna do this in a way that you should not do at home. And let's see. You probably can't even really hear me because of the wind, but I'm gonna attach right now. I'm going to attach the wires, let's see, attach red to the positive. Oh. Sorry, I am not doing this again. I'm just going to do this one time. Here, probably can't see the battery very well. We're probably looking right in the sun. But okay, so what we've got is I'm attaching one end of the cable to the positive. That's to the spongy lead side. One to the lead dioxide side. And then I'm going to move away here a little bit and tilt this down a little bit. Don't ever do this at home, okay? And oops, somewhere there's not a good connection. I would wonder if the battery was dead, but I just drove the truck. Okay, did you hear that? That was a that? There. Good enough. So again, don't do that at home. So what do we got? The voltage is the difference in, it's called the electrical potential difference, and it's the difference between how hard the two electrodes are, one of them pulls on the electrons weaker than the other, and how much weaker is the voltage, or how much stronger is the voltage. Okay, that was probably too much time. Thank you.